Hello, class. We're going to discuss potential energy. We dabbed a little into potential energy during the Work and Energy Lab activity, and during that activity, you discovered that work done by gravity when you lift the ball upwards towards the top of the ramp, or when you let the ball roll down the ramp, you came up with the same answer and the same equation, mgh. We define mgh as gravitational potential energy. Another way to think of potential energy is energy that is stored. An object lifted to any height above the ground has stored energy, because as soon as you drop or let go of the object, it moves. When an object falls, energy is transformed from the stored gravitational potential energy to kinetic energy, the energy of motion. Another type of potential energy is elastic potential energy. Elastic potential energy can be created by springs. When you compress or stretch out a spring, you are storing energy. As soon as you let go of the spring, the object will begin to move. And once again, the stored potential energy transforms into kinetic energy. The force exerted by the spring equals to negative kx. K stands for the spring constant. The larger the value of K, that means that the spring is stiffer. Whereas smaller the value of K, that means that the spring is flimsier. X represents the displacement away from the spring during its relaxed state. The reason the equation is negative is due to the direction of the displacements. The spring force points in the opposite direction as shown in example B and C. We'll use this equation in our lab activity to experimentally find the spring constant for two different types of springs. The equation for elastic potential energy is 1/2 kx squared. This equation is derived from analyzing the area under the spring force versus displacement graph. This area represents the amount of elastic potential energy stored. And that is it for potential energy.